Wonderful. So when I got the invitation, I went to the website and I checked out what the course is about, right? So what's covered in the course, and this is what I found. And there are actually a lot of things here on this slide that I like to talk about, right? So there's a lot of things that I have interest in. So I'm very interested in designing these kind of systems. I mean, there could be you could fill a whole semester talking about designing these systems. Developing and deploying is always very interesting. Yeah, so going to production is one thing, but keeping it in production is another thing. And so that's the maintaining of it and the backend solutions, right? So what's so nice about backend solutions and the infrastructure company we're currently running is that the yeah, it powers every enterprise around you. It's not visible. It's not what the end customers interact with, but it's powering everything. And I was interested in the modern digital enterprise because there's a difference between, I don't know how in the course you define modern, but it doesn't per se matter, right? So the digital enterprise. However, we have a problem, and that's not enough time to cover all these kind of things. So I cherry picked two of them, right? So I want to talk a little bit about the modern digital enterprises, and I make a distinction between digital enterprises and modern, because a modern in this case nowadays, that's all about AI. That's also what we work in as a database company. So I'll get to that in a bit, but I want to talk about that as well. As you heard from the introduction, before I started this company, I had another company, which was a software consultancy firm where I was working for a lot of digital enterprises. I was basically working on bringing these kind of technologies, to their customers. I do this for quite some time now, running this company, so that's quite a long time ago. But still, it's interesting to touch upon. And I have some very, I have some large opinions on this, right? So, or some big opinions on this that I would like to share. And I thought the easiest way to start with the first one is the the two topics that I wanted. So digital enterprises, and I want to talk about modern means, right? Which is AI in nowadays. So let's talk about the digital enterprises. So this is somebody that I often use when I talk about software, open source software, and then especially the business models. This person has nothing to do with software, but I like his business. So he owns a couple of restaurants and a whole restaurant imperium, if you will. This is David Chang, right? So David Chang he's probably, or somewhere officially, he's the CEO of a company, but he is in the restaurant business, right? And when you work in the restaurant business, there's something that we assume from people working in the restaurant business, and that is that we assume that they know how to cook, right? So it's like this is again David Chang, and this is him in the kitchen. I mean, and he's just running his business, right? He has many restaurants, he has books, he has shows, God knows what, on Netflix. He's on Netflix, what, all these things, but he knows how to cook, right? And that's nice, because I'm a big believer in this concept of, and it's like not exactly the same of what the concept means, but it's adjacently related, of like the concept of dog fooding, right? So dog fooding, actually, what it really means is, okay, if you build a product or service, that you use it yourself. But how I like to use it in this specific context is that if David Chang works in the restaurant business, we kind of assume that he knows how to cook. And that is something that I often also say about, for example, if you have if you take the CEO of Volkswagen, right? So the question is like, should the CEO of Volkswagen, does he or she needs to drive a Volkswagen? Do they know how the Volkswagen works? Do they need to be able to just open the hood of the Volkswagen and know exactly how it works? How far do we want to go in that, right? And there's a reason why I do that, because I can see you all sitting here. So not sure if you can see a show of hands, but you all work in technology, or have the ambition to work in technology. How many of you can actually write code? Yeah, so that is like, if I look at, is that half or maybe a third of the room? How much is this roughly? I just A third. Yeah. So this is the point that I want to make, right? So I'm a big believer in, like what we see with in the restaurant business, that we assume that the person running the restaurant business knows how to cook. I am of the opinion that people working in technology should have at least some understanding of what they're working with. And I'll get to that in a bit. By the way, in my presentations, I have a little bit of code because I am dog fooding what I'm saying right now. And if you don't know how to write code, you can still read it. It's not very complex, but it makes our point. Is when we dive into AI, I want to show a little bit of code. And that's because if you work in a digital enterprise, right, you always have to make this decision. Are you going to buy or are you going to build, right? That's always very complex. So some are very lean in one direction, where they build everything. Others lean heavily in another direction, where they buy everything. But most of them, they gravitate somewhere in the middle, right? So if you are now, let's say, a bank, then there's probably certain infrastructure that you're buying, or that you buy services from companies providing the infrastructure, but you actually have a lot of people in-house that know how to build, because of the uniqueness of your infrastructure, especially if you have a large enterprise. And the interesting thing of buying and building is, sorry for my use of memes today. I don't know why I did that, but I thought it was funny to try to capture the memes, right? So what we do when we make decisions about buying and building, right, is that you somehow want to end up on the right end of the spectrum, right? You want to be that, Jedi manager that actually knows exactly what the impact is of buying and especially building inside of the organization, rather than just buying stuff and nutting things together off the shelf. There's a very famous email that you can find from the early days of it's somewhere floating around online, or the story is floating around online from people who are in the know, from the early days of Amazon with Jeff Bezos, where he apparently wrote an email in which he urged everybody to use APIs. In the very early days, he didn't even call them APIs yet. He just called them, I don't know how he called them, but where he urged everybody that every service that we create in the organization should be connected together using APIs. And that is something that leadership or management only can write and only can request if they actually know why you want that and what it does. And I'm a strong believer then that dabbling into the technology yourself allows you to understand it, especially if you work in the enterprise. And it's up to you to decide how much you want to do that. So that's what I meant with the example of the CEO of Volkswagen, right? So it's up to you to decide if you just need to, if you would be the CEO of Volkswagen, would you just want to drive a Volkswagen, or should you really know into the nitty-gritty how the machine works? That's up to you, but you should at least touch upon it, right? There's, by the way, as a last thing to say about this, there's also a downside about knowing too much, because then you can start to micromanage and those kind of things. But there's a very strong case to be made to have some understanding on how these things work. So when we take that as an assumption, right, that we know these kind of things, then there's some core concepts that are interesting and also, close to my heart, and that's like that I find important. And that is one is related to risk management, right? So and taking versus avoiding risk, because if you know how the software and the technology works in your organization, you're willing to take a little bit more risk. And one thing that I've seen from the perspective of now being an infrastructure seller versus a work on the other end of the spectrum in the form of a consultant, is that the knee-jerk reaction of people who do not know how the tech stack works is that they often avoid risk. And if you avoid risk, you're potentially hurting the business. And in a very large company, you don't per se see that right away, but it's something that is, especially if it's in company culture, that can be dangerous, right? So one of the things that I urge, like the first core concept, is like any business today is a software business, and we can only move forward by taking the risk by adopting new technologies and new approaches. So rather than being a risk avoider, try to be a risk taker. And it's like a lawyer, right? The best lawyers don't tell you what you can't do. The best lawyers explain to you how to mitigate the risk that you're dealing with, right? And how can you do that? You can do that by knowing how the technology actually works, right? So, and again, that does not have to be in the metaphor of the CEO of Volkswagen that you need to be able to, open up the hood and, fix everything that's in a modern car. No, not at all. But you should kind of know how the thing works, what the uniqueness is of the car, and that's the same for the technology, right? And then when I talk to people like yourself, I always like to make the case for open source. I am not I'm not religious about open source, as I would like to say it, but a big believer in it, because I think we can build better businesses if, from an infrastructure perspective, we trust. We rely on open source technology. There's a wonderful article that is recently published from Harvard Business School, where they try to research how much would it cost organizations if they would recreate or rewrite the software, the open source software that is currently running in production in the enterprise. And they came up with some nice fancy formulas to calculate it based on lines of code, how long it takes to write them, how many enterprises are running them. And I believe that the number they came to was like something like 8 trillion or something. It's insane. So even if you buy proprietary software, which is fine, there's nothing wrong with that. But know that then there's a lot of open source in that as well, right? So it's very, very, very rarely that the infrastructure stack is really built from the ground up. So that almost never happens. I mean, you could even say if something is super unique, but it's written in C, well, the language of C and the compilers, there can be open source, right? So that's something that almost never happens. And then the question is, so what does open source bring to you? So if you work in the enterprise and you adapt open source because maybe you're tasked with solving a project, working on something, why open source? What are the arguments that you have under your belt, right, that you can adopt? First one is trust. So so the question is like, if we trust software vendors with our data, right, regardless if it's in the cloud or if we keep it on-prem, however we deploy it. And on-prem nowadays means in the VPC, in the virtual private cloud, we get to that. But there's trust, right? So because if software is publicly available and if people are contributing to it, and contribution is, especially in infrastructure, that's not in the form of actually writing code. That happens only sometimes, but it's way more in the community that exists around that, right? The community that emerges, but also the feedback that are people giving to the software. I mean, the most important product feedback that we get to our database is not coming from our customers. It always comes from the open source community first, and the customers benefit from that, because if we solve it for the customers, for the community, the customers benefit from that. So it's the community that comes with that. One of the things that you might know or might not know, but if you have an open source business, an infrastructure business like I run, you actually sell through the community. So you might, when you're a technology manager, you might task somebody in your business to solve a problem. In our case, those are what we call AI native applications. People start to work on that. They might adopt some open source technology. That might be Weaviate, that might be our technology. And they reach out to us. We connect with them through our community. We call that the champion in your organization. And that's how you sell up to the organization. So community is a win-win, both for the business that you're supporting, but also for us, right, to interact with you. And last but not least, it's architecture. And it's a little bit abstract, but if I explain it, it probably explains itself. And if you write software, there's a concept that is, I believe, from the top of my head, it's I believe it's Conway's law. I might be off. Let me double check to see that what I'm saying is correct. Yes. So there's a concept called Conway's Law. And what Conway's Law basically describes is that it says that that if you create software in an organization, you can see the communication lines of the organization in the software. And that also goes on an abstract level. So your software evolves in how you deploy it. So, for example, if let's take a famous piece of infrastructure like Snowflake, right? Snowflake is closed source, proprietary, which is fine. But the way that it's deployed, so that it has this economies of scale effect on those kind of things, probably means that if they would open source it, you couldn't really benefit from it, right? So you might find some interesting nuggets how they solve problems, but it's not that you just can copy paste it and run your own Snowflake, right? And what happens with open source technology is that open source technology, especially infrastructure, often compiles itself into a single binary, and we try to take as many paths or as many channels to provide that software to our customers. And the upside of that for you in the enterprise is that there are a lot of deployment methods, especially nowadays in 2024 and beyond that, right? So if your business wants to adopt serverless, so that's in the case, for example, of what we're building, Weaviate. If you want to adopt serverless, just a cookie cutter service, swipe your credit card, good to go. We have that. On the other end of the spectrum, we have bring your own cloud, which basically means, hey, you might be a customer of one of the hyperscalers. The hyperscalers, we mean AWS, Azure, or Google Cloud. And so, and you might say like, hey, we need to run the infrastructure inside our virtual private cloud. You can do that too. And in the middle of that, you have something that we call enterprise dedicated, and other companies have different names for that. But what that means for us is basically it is managed by us, but you get all the knobs and whistles and bells and what have you to tweak your infrastructure. Why is that important for you as a maybe you're already working in the enterprise as a tech lead, or maybe you're aspiring to it, is that if you need to make a decision on core infrastructure, then if it's open source, chances are that the complexities that come with your business and how you want to deploy it can be solved. And that's not always the case with SaaS. So that goes back to this little joke, this little meme here. What this meme shows here is that on the left-hand side, and I've been there early in my career, you're like, oh, I'll just build it ourselves, right? We'll do it ourselves. And then, oh boy, there's so many business complexities that you have to deal with. And then you sit in the middle and you're like, oh, I just want to buy some SaaS, just get it over with. But now you might have the technology, but now you're still dealing with this problem of like, how are we going to deploy this in our business? So where you want to sit is at the right-hand bottom, right? That, if we properly build it, if we properly execute on it for our business, right? We can have the best of both worlds. We have a little bit of SaaS, a little bit from the infrastructure, a little bit to align with our business. And that is something that open source gives you. So to recap those kind of things, right? So what I just talked about is like, if you have understanding of how the technology works, it allows you to take a little bit more risk than avoid it to help the business. Because if you're a business owner, you're just taking risk all the time. That's like, or well, you're mitigating risk all the time, right? So you want to help your business by taking a little bit of risk. And open source might help you in that, because especially to the architecture, the community, and the trust that is built through that, you kind of understand and you kind of know like, okay, probably we can deploy this inside our business. That is what it brings to you. And then the last thing that I want to talk about, so, and that's like the third point, is modern, right? So I made an interpretation of modern. You're a fancy university, so you probably have all kinds of fancy definitions of what these kinds of words mean, but I interpreted this as AI nowadays. And it's a little bit self-serving because I run a business in AI, but still. So, and to explain a little bit of what's happening, I want to go a little bit back into history, right? And do we get on what we're doing? And that's because we work in AI native infrastructure, and then specifically the subset of that is so-called vector databases. We'll get to that. And the pessimistic view might be like, hey, this is just another data type, these vector embeddings, and therefore it's another NoSQL database. I actually make a different argument, and I believe that what AI is enabling us to do with infrastructure is open up the door to something completely new. Yes, NoSQL is super important. That's not going anywhere. But rather than adding to it, it's something new on top of it. So in, around the 1980s, we had the whole SQL or SQL epoch, right? And we had some winners in there, right? I mean, the big winner, of course, is Oracle. Oracle now owns also MySQL, which was the open source equivalent, but also Microsoft a bit with SQL Server, right? Transactional databases, as you will, right? The technical term that we always use for that, or also use for that, is OLTP, where the T stands for transactional. What might be interesting to know, to double click on, quick show of hands. Do people know what a transactional database is? What the T means? What transactional means? I see no hands. So let me quickly double click on that. You might find it interesting to know. So if you build a database, you need to ask yourself the question, why do I, what do I want this to do? Do I want it to be fast? Do I want it to be reliable? Those are trade-offs you make in the architecture of building it. And a way for, let's say that you have an e-commerce project. Let's say that you create a database and you have an e-commerce inventory, and you have 2 products in there. And the inventory of one of the products is 10. So you have one product with 10, an inventory of 10. Now, the problem is that if the system is used a lot, right? So think about, for example, a bank, right, where a lot of transactions are happening, or like a retailer or a wholesaler, like the Amazons of the world, etc. The problem is, like, let's say that you want to update the inventory. How do you do that? So one way of doing it, and that's a little bit the naive way of doing it, is that you could take the product out of the database. So let's say that you want the inventory to go down with 1. You take the product out of the database. It says, I have an inventory of 10. You remove 1. It's 9. And you put it back, right? And it says 9. But that takes some time. That takes a couple of milliseconds to do, right? So let's say, for sake of argument, 10, whatever, right? 10 milliseconds. The problem is that if you have a system that's used a lot, but like a lot, and you want to guarantee that works, you need a transactional system. Because let's say that we take it out, and now we have a time window of 10 milliseconds where we remove something from inventory. If now within that 10 seconds, somebody else wants to add something and they take it from inventory, what happens is this. We take it out. It says 10. In the meantime, we take out another one, also says 10. This one goes to 9. We put it back. This one goes to 11 and we put it back. And the inventory in our physical warehouse should say 10 because we took one out, we added one, but in the database, it will say 11. And you could imagine, especially if you're like a bank or like a wholesaler, like the Amazons of this world, or the IKEAs of this world, or the Nikes, or what have you, we cannot have that. Because if that goes wrong, there's a complete mismatch between your inventory and what's really there. So think about everything, time series management, things related to finance, inventories, stock, all those kind of things. They ask for transactional databases, and the abbreviation we use for that is the OLTP database, and the T stands for transactional. But then we got other databases that are OLAP, because the problem is that this comes with complexities in the database, and sometimes we want to do other things with our databases. And a famous example of what we might want to do with these databases is analytics, right? Analytics are a little bit different. We just want speed. We have petabytes of data, terabytes of data. We want to search through them quickly, get to our insights. We don't care about that whole transactional thing. So now the architecture of the database changes. We might still use SQL for it, but there's a different use case. A great example of a great business there is Snowflake. That's what Snowflake is, right? But now the question became like around, like just after the 2000s was like, we still need a lot of software infrastructure in our business. We still need a lot of databases, but it's not really SQL because we might want to do search very well, or we might want to build applications that we can quickly bring to developers easy, right? And we just don't use SQL for that. It's just different how it works. It's different how the architecture works. And there we see big winners like the MongoDBs and the Elastics of this world, right? So MongoDB is loved by app developers. Elastic is loved by people building logging services and cybersecurity services. Those are all infrastructure. Those are all databases, but they're not SQL. So now what started to happen was when these machine learning models came to the scene, and I started working with them in 2015, was actually that the data that's coming out of these machine learning models was a little bit different. They're so-called vector embeddings. I just want to be, careful with time, so I'm not going to double click too much on it, because if you Google what's a vector embedding, the internet is full of it. But new databases started to emerge that started to do that started to interact directly with machine learning models. And that's what Weaviate is doing. And that is what I would argue is a new epoch, right? That is where we sit. So Weaviate, and what's in the name, weaves the data and the infrastructure you have in your business and the machine learning models together. So that is what I would call the third epoch. So we went from SQL to NoSQL to AI native. And to explain how that works in a little bit in an abstract way, but in a way for you to deploy that on any use case that you might have, I have a little bit of code to go over that. Oh no, first I have a diagram, right? So to show what that is. Internally, we call that feedback loops. So the feedback loop is you might have a GPT model, for example, right, that interacts with the database. You might have a vectorization model that takes your data, can be text, images, audio, what have you, that creates so-called embeddings for them. That is the data type that the models like to interact with. But we can create, as you can see, this goes in a circle. We can create feedback loops with that. And so what you basically do, you have a user. In our case, that's often a software developer. The software developer uses a driver in Python, or TypeScript, or any other, or they store information by vectorizing it. So by telling the machine learning model, this is the data that I'm going to store this for me. Or we can now use the LLMs or by actually the multimodal model. So just for your understanding, LLM stands for large language model. That was last year, the whole craze, like with GPT, and now you see it with other models as well. But this is the year of the multimodal model. So the multimodal model, it takes in text, but it also takes in video, audio, images, and it outputs that, right? So that's the multimodal model. Or we can, as a user, store data directly into the database. But the important thing here is that the model starts to interact with your data. So what can we do with that? Why is that new, right? So let's say that I have an instruction, right? So I have an instruction about my data, and I say name and description should be in English, right? That is the description that I'm giving. And let's say that I'm entering some data, and this is Airbnb data. The use case is Airbnb data. So as you can see, the properties, a name, MJ Stay 1, and in a town in Korea. We have a description, which is clearly in Korean, and we have a price per night. And the problem is all existing data systems work like this, even on Airbnb right now, right? So if I store this piece of data, this is literally what's stored in the database. But what we're instructing the model with is that name, so here you see name, and description, you see description, should be in English. So what now happens is that if we store that data and we get it back, so we say fetch object, we'll actually see that how it's stored is that it says basic cooking utensils and tableware such as pot and frying pans are provided, etc., etc. That's actually what it says here in Korean, right? So what we start to do, and that's a uniqueness that's happening. Oh, this is also for the vector embedding. You can ignore that for now. But what actually starts to happen is that in this case, large language model, but it can also be the multimodal models. They become our database admins. They start to create, update, read, or delete data for us. So 89% of data is unstructured in the world right now. Dealing with that, cleaning with that is a huge problem, right? And what now starts to happen is that the models start to become your database admins for all kinds of workloads. And that is what I call AI native, right? That's that new step in technology. So that's all. That's what I wanted to share today in the time that I had. I hope this was helpful and insightful, and I'm happy to answer a couple of questions if you have any.
Thank you, Bob. So open.
Thank you.
It matches very much with the which you did the database, and also with the next week, which you're going to do a little bit about hybrid intelligence, how AI will help us work together like a collaborative way. So yeah,
yes.
For questions. Anybody? Especially these technical guys that are there. Yeah. Maybe a bit louder. I can repeat. Is it possible to encrypt vector embedding?
So that depends a little bit how you look at it. So if you mean literal encryption, you can of course do that. What you cannot do is that sometimes people have mistaken the vector embedding themselves as a type of encryption. So for those in the room who do not know, a sentence gets, for example, if you talk about text, a sentence gets a numeral representation in the form of so-called floating points. So if you have the sentence, Bob gives a talk at Aarhus University, then the output of that might be an array of numbers. And sometimes people pitch that, they say, hey, that's a form of encryption, but that's actually not true. There's now quite some scientific literature where they can quite well, not 100%, but decipher what's in a vector embedding. So the vector embedding itself does not count as encryption, but if you just want to encrypt in the database, you can, of course, you can do that.
So how do you see that database is that kind of replacing the SQL info or being complementing existing SQL?
Yeah. Can somebody repeat the question a little bit closer to the microphone, because I did not hear the question.
It's like, how do you see the AI, vector database as is like complementary to SQL, or is it replacing the trend for the future?
Yeah. So what I believe is that what it's mostly going to change is how we interact with our data. So the status quo today, we are so used to like we're literally storing the data that we get in the database. And then that's also what we get out and what we present to our end customers or end users, right? We are not used to this way of working that there's a model sitting next to the database that helps us better, more efficiently, etc., store or retrieve that data. So that was the example I was giving in the demo, right? So if you say like, oh, as a data, somebody is responsible for data management, everybody should store the data in English, right? That's just an example. But if people don't do that, right, Then what? And now today it's just stored in the databases, however people store it. But now you can give the model the assignment, say like, hey, if you encounter something that's not in English, just translate it to English. But it could also be the case that if somebody, let's say that you say all data we store in our database should follow the metric system. So if then somebody stores something with and says like 10 gallons, then it's the model that's actually updating that to liters, right? And we can go very, very far with that. It's just the model helping you to do data management. So to answer the question, I think this is a completely new paradigm, how we start to work with our data. This is not doing something faster or doing something more efficient. No. It's a complete new paradigm, how we're dealing with data management.
Thank you so much. Any other question? Well, I have a question like, because you were speaking about open source and trust. Yeah. So how do you see the AI in the trust? You know, like, let's say, like, because can you trust, like, you talk about trust, like, it's open and stuff, but the AI can do like stuff doing like its own things. Like, so how does do you bet the trust decide well?
So, I think what's very important to bear in mind is that the model that we're using, or any model that you're using, right, is a bunch of weights, right? So it's a bunch of weights that makes a prediction, especially if you look at generative models about like practically we call it tokens, but let's park that one. So word after word after word after word. So that means that it sometimes might be wrong, right, in how it predicts word after word after word. So the case that I was just making for an LLM helping you to do your data management better and more efficient comes at the cost that it's just not a binary output and that it sometimes might be wrong, right? That's the cost. That's what we're paying with, if you will. I don't mean financially paying, but it's like that's the cost of the innovation, basically. And on the other hand, you can answer. So what I meant with trust here: can we trust the model? Well, not in the sense of that we do not know what the output will be. We can't guarantee the output that's coming from the model. But the business value that's coming out of using the model is in some cases so large that it's just fine to accept that risk, that it's sometimes wrong, right? And that is the example that I gave with risk avoidance versus risk taking. Because if you're risk avoidant in your business, you might say, oh, let's not use AI because, it can be sometimes can be wrong. But what you're throwing away, what's the saying, the child with the bathwater, right? Because you're missing out on all this opportunity, right? So that is why I'm inviting people just to take one step further and mitigate that risk. The other thing about trust with open source is the model itself. Because a model is stateless. That means like an MP3 file that you might play is that if I copy paste it and I have two of them, I have twice the value, but I might from a business perspective not be able to capture the value twice. That means that to bring these models to the world is that we need to come up with Spotify-like models, as I like to call them. And I don't mean machine learning models, but business models. So that they sit behind a paywall. And so, for example, if you use OpenAI, right, you need to make an API key, you get access to it, and you get that stuff back you can use in your business. But the issue with that might be that you need to send that data over the wire somewhere, and then, you don't know what's happening with that, and then something comes back, right? For a lot of use cases, that's fine, but sometimes it isn't. And there, open source, again, plays a role. And now the trade-off is like, buy versus build. If you are building a customer service platform, you're probably fine with using that service. But if you're using it for legal documents or those kind of things, you want to have maybe a little bit more control and keep the data closer to you. And meaning that you will need to operate the model yourself. And so that's again that trust trade-off between the businesses that you're working with and the open source models that just are, you know, you to use and to take and control yourself with, and then you have like a 100% trust guarantee, if you will. So that those two trade-offs you have.
Super. Any other question? Yeah, we have one from
Is it like the elastic search and plus AI powered searching methodologies like elastic search is like inverted index way of searching text and data, right? Okay, my question was like, is it like a VIP elastic search plus AI? Is it that the searching?
both it's like the combination of is like embedded from what I understand is like is the embedded like inside is the two different paradigms like the database and the machine learning, or is like kind of embedded one thing like how you operate like your database like operations like that's what
Yeah, I mean, elastic search is like an inverted index data. But Weaviate is doing the vector database scanning with AI powered. So my question is like, is it like elastic search plus AI make the search faster and with the power of AI that search more faster than that? Right now, elastic search is doing.
do you hear the book?
No, I can't hear it. So it sounds like a very interesting question, but
It sounds like it's like if I go to
Elastic search is a
yeah, Elasticsearch is a tool, and then
like elastic search doing inverted index searching, and Weaviate is like a vector searching. My question is like, is it Weaviate is equal to elastic search plus AI?
yeah. So he's asking like that Elasticsearch is like a reverse index searching. So is it comparable like that? What they're doing is like it's comparable to the vector search engine which you're doing is like comparable to Elasticsearch plus AI or correct? Yeah.
so I think I understand the question. So is the question, is the vector index comparable to the inverted index in Elastic?
Yeah, exactly. Yes.
Okay,
Yeah,
thank you.
exactly.
Yeah. No. So and let me double click a little bit on that, right? So the inverted index is a completely different type of index than the vector indexes. So the actually in Weaviate there's also an inverted index for the key value store. Making a vector index is you basically need to solve a couple of problems. So the first problem is that if you do brute force vector search, you could do that, right? So you take an embedding, you compare it to another one, same embedding, compare it to another one, same embedding, compare, etc., etc., etc. That's the brute force method. The problem is that that gets slower in a linear way. So if you store 1,000 or 10,000 data objects, you don't notice it. But if you have like 100,000, a million, let alone billions, it gets very slow to get an answer. And if you have real-time use cases, that's problematic. And therefore, there was these algorithms were invented, called approximate nearest neighbor algorithms. And what you basically did was that these algorithms were able to very fast do vector comparison at the cost of approximation. So you can't have 100% guarantee that the actual nearest neighbors are the actual nearest neighbors. You might miss one, if you will. But the thing is that there's so much faster that the trade-off is perfectly fine. And we're not talking about like 80% and 20%, but we're talking about like 99 point whatever percent, but not 100, right? So that trade-off, that was like very valuable. Now, the thing was, if you open up Elasticsearch, what you see under the hood is something called Lucene. Lucene is an inverted index, which is it's very old and it's very widely adopted, and it's a great piece of technology that great people have been working on. But the problem is that the way that Lucene is built from an architecture perspective is not optimal for the vector index. And this is why you saw these new indices and these new databases being created and not have this added to Elastic early on. And now you might say, like, well, but now today they have it. Yes, that's true. Today, every database supports some form of vector search, which is great because it shows that there's value in the market. But the thing is that the way that the indices work are very different. If you really wanted to go into the nitty gritty, I would highly recommend on the Weaviate website, you have a blog and you can just read about it and exactly how that's built and get some background information. And by the way, because I'm looking at the time, I need to, I'm already 5 minutes late for my next appointment. But what I want to say is the website contains a lot of information and I would invite everybody to just find me on LinkedIn. And if you have any additional questions, just shoot me a message on LinkedIn and I'm happy to answer all the other questions that you have. But this is great. So I hope you enjoyed it.
Super. Thank you so much, Bob. I will share the information. I will put in the bright space like which you give all the materials for the students. So if anybody wants to contact you, I'm pretty sure they will be. And thank you once again for the fascinating talk and for the fascinating new technology which you bring. Like now, I get it very much. So yeah, once more, let's thank Bob. And see you around.
Thank you.
See you also here in Denmark sometime. Like.
Thank you. It was wonderful talking to you. Bye bye.
All right. Thanks.